Welcome to Wiring Methods Lab number 3. This week we're going to be dealing with a switch and a light. You may think that sounds a little familiar because last week we were dealing with a switch and a light. Last week our switch, our home run came into the switch, and then we had a switch leg running up to the light. This week our home run comes in at the light, and then our switch leg drops down to the switch and comes back up to the light. That is going to require a significant change in the way that we wire this particular circuit, and we're going to talk about those changes as we move through them. The first thing I'm going to do is I'm going to draw in our two pieces of cable. We have our cable coming into our lighting fixture junction box, and we have a piece of cable running to the box for the light switch itself. We're going to start with our light fixture box. We have a hot coming in, our black wire coming in, we have our white wire, our neutral coming in, and I'm going to leave the grounds out for now for clarity. We'll add those in at the end. Every device has to have a ground installed to it, but for clarity of drawing everything in, this is going to get a little more complicated than the last one. I'm going to leave it off until we get to the end of this project. So last week we talked about every circuit that we design in a building. That's my battery, my power source. We are going to break the hot wire, our black wire. We're always breaking the ungrounded wire. And then our neutral remains unbroken all the way back to the source. So, same situation here. Our source is off in this direction, and so our neutral, it is going to go straight to the white wire. It's going to go straight to the neutral portion of this light fixture. We've connected the white directly to the light. That's what we were hoping to accomplish. The neutral side is unbroken. It's been connected with a wire nut, and it has been connected. Well, now if from this point, if I tie my black wire here, if I attach that straight up to my fixture, that light's going to come on. It's never going to turn off. We will have bypassed the switch. That hot wire needs to be broken by the switch. That black wire needs to be broken by the switch. And so we're going to take that black wire that's going down to the switch, and we're going to connect these two using a wire nut so that we can get our black wire down to the switch to be broken. Well, now we have to get a wire back up to the light, and in years past we were able to use the white wire. We were able to redesignate that white wire as a current carrying conductor by placing tape on it, covering it with a marker, or putting paint on it. We could use that as our current carrying conductor to get back up to the light. And there are still instances where that is possible, but in this particular setup, we cannot do that. And the reason we cannot do that is because I need my neutral. I'm going to tie another wire into that wire nut with my neutral, and I'm going to bring it down into this box, and I'm going to just leave it dangling there. And the reason I'm going to leave it dangling there is because NEC code 404.2c says that we are required to have a neutral at every lighting location. In every room that has a light, one of the switch boxes for that light has to have a neutral. And the reason it has to have a neutral is for future technology, right? We don't know what future technology is out there, and these homes that we're building are meant to last 30, 40, 50 years. And so we want to provide a way for future technology to be able to be used in that junction box where the switch is at. We're already seeing technology, Alexa, Siri, Google, where we have devices that require power, which would mean they would require a hot and a neutral that can control devices in our home. And so it is not a leap to believe that at some point we may want to replace this switch with some sort of smart device that requires a hot and neutral to control the light switch. So the 2020 and 2023 code says that we have to have a neutral pulled to that box, and that we can't use it for anything else. So we're going to just stick a wire nut on the end of that white wire, and it's not going to get used for anything, but it must be there. So now we're short of wire. Well, we can't use the bare copper, and so we must use a piece of cable here. This piece of cable, instead of being a piece of cable that has one hot and a neutral, we need a piece of cable that has two hot wires, two ungrounded conductors, a black and a red, and we will bring that red up, and that red will be what we tie in to our light fixture. And that third wire is what we're going to use as our traveler back up to the light fixture. Now we'll go in and add our green ground, which will attach to our light, and then with the wire nut also come down and across and get tied into our switch. But it's our wire nut on there. And now what all this allows us to do, if I flip this switch up, my light comes on, because we have created a path for the electricity to flow in on this black wire through the switch, back up the red wire, into the light, through the light, and then down our neutral back to the source. We've created a path for the electricity to flow all the way through. And hopefully that's neat enough so that you're able to gauge what we've done there, and you'll be ready to work on this project when you come in on Tuesday.